So in this question, we are looking at domains of the sum function. So we have two functions, f and g. So we're looking at the sum function, determining the domain of the sum function. So let's look at what the sum is. So we just add the two functions to get 1 over x squared plus radical 1 minus x. So that's the sum function. Where exactly is the sum function defined? We need to make sure that the function f is defined and function g is also defined, but we have to get rid of those numbers where either f or g is undefined. Okay, so we have all reals except 0 for the domain of f. The domain of g is all reals less than or equal to 1. And why is that? Because we are looking at a radical function. A radical function is defined only when the inside of the radical function is greater than or equal to 0. So we have 1 minus x, which is the inside of the radical function, greater than or equal to 0. So 1 minus x is greater than or equal to 0. I add x on both sides to get x less than or equal to 1. And I can write it as an interval negative infinity to 1, including 1. So we know that the function f is defined at all reals except 0, but in the domain of f plus g, we cannot include anything greater than 1. So we're looking at the domain of g, which is negative infinity to 1, and getting rid of 0 at which the function f is not defined. Okay, so we're looking at the two domains and looking at what's common between these two, and that's what is the domain of the sum function. Because remember the logic of the domain. Both the functions have to be defined at these numbers. So that's why we have not included any number. So we started with negative infinity to 1, right? So we know that in this interval, both f and g are defined except at 0, and that's why we took this interval and excluded 0 from it to get the domain of our function. The next thing is the composite function, or the composition of two functions. So f composition g of x is f of g of x. So g is the function that's first applied to x. So we get g of x equals radical 1 minus x. So it's f of radical 1 minus x. So now what does f do to any x that's plugged into it? So f of x is equal to 1 over x squared. Let me double check. It's equal to 1 over x squared, which means whatever you plug into x, wherever you see an x, you replace it with that number and square it. So basically, if I'm going to replace this by radical 1 minus x, then that's what I plug into this function, and that's how I get the 1 over 1 minus x. Now, finding the domain of the composite function is just basically using your logic. So since g is the first function that's applied to x, we start with the domain of g, not the function, but the domain of g. So at least g has to be defined. For g to be applied to x, x better be in the domain of g. Okay, but now we're going to apply f to the function g, right? And we know that f is undefined at 0 because 0 is not part of the domain of f. So therefore, if g of x, which is this, is equal to 0, then f is not going to be defined there. So let's see when this happens. Let's square both sides to get 0, which means x equals 1, right? So when x is equal to 1, g of x will be 0. If you apply f to 0, then it's undefined. So therefore, what we need to throw out of negative infinity to 1 is the number 1. So this says that 1 is included. All we need to make sure is 1 is not included, right? So we need to throw 1 out of the domain. And this is how we get the domain of the composite function.